The Workplace Safety Awareness Council's put together a little the trainer's guide to electrical safety, and basically it's looking at OSHA regulations and some workplace violations that we can avoid. I'm going to go through this. I'll also give you the link because it's a really large document, but let me give you some of the highlights. And I'm highlighting these also because they're the most important things, but I want you to remember to come back here as you go through the module quiz, because since it's highlighted, it's going to be some of the most important things, and so you'll also be assessed on it. So I've already made the point that you definitely are responsible for your own safety and the safety of your employees, but you've never really seen just how little energy it takes to kill someone. So when you were looking back at Ohm's law, you saw some reports on 300 milliamps, very small values here, and they were just basically created by a small battery. Now, these small batteries don't necessarily have enough charge to last, but think about this. If you have a pacemaker, for instance, where are you getting that energy from? They're typically relatively small energy storage devices. So you don't necessarily have to have a whole lot of charge available in order to have some detrimental effect on the human body. So it takes only about 3 milliamps, a very small amount of current, in order to cause some harm to a human. And if you've ever been electrocuted, typically you either get pushed back or your muscles will actually contract, and that's because everything that works within the human body is electrochemical, and so we respond pretty poorly under electrical influences. It really messes things up. It's very dangerous when you have the can't let go phenomena, especially since, well, you can't stop. And chances are, with such a low current difference here, you're not actually going to trip any breakers or blow any fuses. Now, it's also possible that you're working on, say, a ladder or from a high height, and you could be thrown backwards because muscles work in those strong responsive ways. So both are pretty much undesirable situations. So you can see it doesn't really take much for your heart to respond differently than it should, and then of course only in about 1.5 amps we begin to singe and burn internally and externally. So it's not a lot of energy, not a lot of charge has to flow through a human in order to cause us damage. Think about the size of a typical lighting circuit, about 15 amps. There's not really much going on there in terms of what a circuit breaker sees. So this is why we have things like ground fault circuit interrupting devices, GFCIs, or sometimes called GFIs, and they're built in line because they see a difference between the loads and the lines. So this makes my point. A little 15 amp circuit breaker, again a typical lighting load, maybe a residential circuit, really not meant to design, not meant to protect people, just to protect equipment. So some common sense is meant to protect people. We've talked about arc flash many times, the surface of the sun, as we've seen before. And arc flash is, of course, a very serious issue, and it shows up often in the NFPA. The NEC's code, of course, is built off of them. A little bit of a graphic discussing that blast zone, if you will, or that flash zone. And you can imagine that WSAC is going to spend a lot of time on the NFPA 70E, which, if you remember, important to remember this, is the arc flash standard, basically. So there's a lot of protective methods that make a lot of sense. You want to make sure you de-energize the circuit, which, again, you should be using the lockout tagout procedure. Have proper work practices. Make sure that you're using insulation, which can be actually on gloves, that can be your boots, they can be the actual wrenches and the other tools that you're using. They can actually be insulated. It really just depends on the situation on how much insulation you expect to have. But each tool is rated for different scenarios: residential, commercial, or industrial. So again, just taking some sense of the safety of your area. And I already mentioned GFCIs, making sure that you have proper ground fault protection. And of course, in some situations, you need to actually be grounded yourself, or the equipment needs to be grounded appropriately. It depends on what you're using. Some small-scale electronics versus large-scale electrical situations. Everything's a little bit different, but the physics is all the same there. And then this goes in and discusses again the LOTO, lockout, tagout, discusses all of the information on who's actually qualified to do what work. If you don't know if you're qualified or not, my guess is you're not qualified. You want to make sure you have a qualified person on here. And then really for us, the PPE is very important. You want to make sure that you have your safety plan, and PPE should always be a part of that. And it goes through and talks about what you need to protect your head, what you need to protect your eyes, and the different types. Here's eyes and faces. Again, arc flash is going to show up constantly here. And then potentially for the body. This is all based off of electrical PPE, so don't think that body protection isn't important. It's definitely something that needs to be considered. And don't forget also that the type of clothing is also related to how loose the clothing is, and what's going to happen if it's under the influence of fire or something similar. And then of course you have PPE, and you want to make sure that you inspect and maintain everything. Even gloves need to be maintained. You'd be surprised how many issues can happen when gloves just are allowed to get old and deteriorate. So that's protection for your hands. Believe it or not, Salisbury is a company that produces gloves. Believe it or not, there are many different types of gloves for many different scenarios, and they're color-coded, as they should be. So you can look up what your workplace environment is going to be like, what your voltage class is going to be, and you can see what gloves you're allowed to use. Okay. And make a little note here, it's actually the tag that matters the most, especially here. Salisbury is the group that was producing those. So again, very important maintenance. You want to make sure that what's keeping you safe isn't getting old, isn't getting deteriorated. Lots can tear down on these gloves and other materials. Here's an example of those insulated tools. Again, explaining what has to be worn. This is a whole process when you're designing your PPE. It says the employer shall access the workplace. Shall assess the workplace to determine if hazards are present or are likely to be present which necessitate the use of PPE. So whose responsibility is it? Well, it's the employer's, but it's the employee's safety, so they need to have a buy-in as well. And there's written certification here, so that's your PPE plan, your safety plan. So you evaluate, you assess the workplace, and there are levels of responsibility for these, and they have to be recent, or they have to at least be on a periodic maintenance schedule. Alright, so more discussions when you can actually categorize. You can take an assessment of risk, and you can say, alright, well, in this situation we need a hard hat and safety glasses. But in a higher risk area we need hard hat, safety glasses, this type of safety glass, we need hearing protection, we need a flash suit hood. So just some examples here. And it gets relatively complicated, so you need to assess the situation, see what class, what division you are, and see what group you're in, and then decide how to mitigate these hazards. I mean, a lot of us are not going to be working around grain, dust, flour, starch, cocoa, or anything like that. There's a purpose for that. These are very combustible materials when they're all packed together. Group F is a little more obvious. Maybe Group E is a little bit more obvious. But again, this combustible dust, maybe not something that you think of. But if you're working in a very dusty, old, musty situation, maybe there's even a lot of moisture in the air, you can have the potential for arc flash, and if it's really, really dry, then you can have the potential for additional combustion. So there's really a lot to consider here. So very valuable information. I encourage you, based off of your background knowledge, based off of whatever work environment you're working in, to go through and use this kind of as a starting point, because again, OSHA.gov is referenced here, and the NFPA and the NEC, they're referenced here constantly. But they're just some really useful and valuable safety strategies that you should be employing. And again, one last thing, never operate on a live circuit. That's all I got to say. Thank you.